In this session, we will study about the inverse of a matrix by elementary transformation of rows. For this, we use this concept here. Look at this. Here, matrix A into A inverse is equal to identity. First, I would explain you this thing. If we have to multiply any number with its reciprocal, if we have a 5 and we multiply this 5 with its reciprocal, we always get 1. So the same concept behind this, matrix A into A inverse is equal to identity matrix. And what we do, by the transformation process, we convert this matrix A, into I by the transformation process. And as we do change on the left side of this equation, the same change we do at the right side of this equation. So this identity matrix automatically becomes A inverse when it converts into I. So this process, because any number, if we multiply it with 1, we get always same number, because it does not lost its identity if we multiply any number with 1. 1 is the multiplicative identity. So this thing we use here for solving out the questions regarding the inverse of a matrix by transformation process. Now I would like to tell you about different steps how to convert this into identity matrix. So look at this. We have a matrix A square matrix of order 3, A11, A12, A13, A21, A22, A23, A31, A32, A33. These are the elements of the matrix, and these are the columns. This is the C1, this one is C2, this one is C3, and these are the rows. This is the R1, R2 and R3. Here you see in identity matrix of order 3, 1 0 0 0 1 0 0 0 0. So we have to convert this first element A11 into 1. We have to transform it into 1. So how we get 1? So I explain you here. Let us see. R1 first row times to R1 divided by A11. The same element here, if we divide the any number by the same number, we get always 1. So this is the first step we have to use to making 1. For making 0, what we have to do? Now here element 21, we have to make it 0, because in the identity matrix it is 0, and A31 is also 0, so we have to make it 0. So what we will do with row 2, R2 times to R2 minus, because the value of this element what we have to make 0 is A21, and we multiplied with row 1 element which is now 1, because we have done this step already. R1 times to R1 upon A1, which we have made 1. So R1 is 1 now, so we have to make R2 minus A21 into R1. If we multiply this A21 with 1, it will be A21, and we subtract this, we get 0. So in this process, R2 become 0. The same process we have to do for R3 also, for A31 also. For R3 minus A31, this is the A31 element, we have to make it 0, because here it is 0, into R1. R1 is already 1 there, so we get here also 0. So this way we could convert the elements into 1 and 0. So we could make easily the identity, we could transform this matrix A into identity matrix. As it converts into my identity matrix, the matrix identity matrix will automatically convert into A inverse. The same process we have to do on the right side of that. So we take one example for this. I solve one example for you for getting better understanding of this method. Now I take this example I have taken here. There is a matrix, a square matrix of order 3. The elements in the first row are 2, 3, 1, and the second row 2, 4, 1, and the third row 3, 7, 2. So I write down first the concept here. A into A inverse is equal to I. So in this way I arrange these matrices. So I get one. This is the matrix A we have taken, and this is the A inverse and the identity matrix of order 3 we have taken here. So what we have to do, we have to make this element 1 is this element A11, which is 2, is equal to 1. So I explained you earlier the steps how we have to make it. I explain it again. So R1 times 2 R1 divided by A11 is 2 here. So we do this thing here. So we get now here you see we do this operation with 2 divided by 2, it will become 1. So I write here it is 1 now. 3 divided by 2, it is 3 over 2 here, and 1 divided by 2, it is 1 over 2 here. The elements of other rows would be same as it is, so we are not transforming there anything. 2, 4, 1, and 3, 7, 2. This we have got here. Now A inverse is already there. The same process we are doing on the right side. So here 1 divided by 2, it is 1 by 2. 0 divided by 2 is 0, and 0 divided by 2 is 0. The other rows would be same. So this we have got here. Now what we have to do, we have to make this element 0 and this element 0. Here you see in the column 1 in the identity matrix this is 0, 0, so we have to make it 0, 0. So what we will do now, explain you. We will do R2 times 2 R2 minus 2, because this element is 2, we multiply with 2 this 1, so we will get 2. 2 minus 2 is 0, so 2R1. This process we have to take, and for R3 we have to make 0. It is R3 minus 3R1, because it is 3, the element value is 3, so 3R1. R1 is 1 there. So we make it now. Look at this. The first will become would be same, because there is no transformation in first row. So we write as it is 1, 3 by 2, 1 by 2. This you see here I write this thing R2 times 2 R2 minus 2R1. For this element here you see R2 is 2 and 2, R1 is 1, so it is 0 now. So we get here 0. Here you see it is 4 minus, we have to multiply this 4 with this and subtract from here, so minus 2, we we have to multiply these two, and the R1 is 3 over 2. So we get here 4 minus 3, which become 1. So we get here 1 now. It is 1. Now here it is 1. Just I change the color. It is 1 minus 2 into, it is 1 by 2. It is 1 minus 1 would be 0. So it is 0 here. Now we have to make this 3 is also 0. So we have R3 tends to we have R3 tends to R3 minus 3R1. For this, we know that R3 is 3 and 3 into R1 is 1, so we get here 0. So it is 0 now. For here, see, it is 7. So you write 7 here. 3 into, and this R1 is 3 by 2. So we get here 7 minus 9 by 2, which would be 14 minus 9 over 2, which would be 5 by 2. 5 over 2. So it is 5 over 2 now. Now we see the last element of this column, this row. This is 2 minus 3 into 1 by 2. The element is 1 by 2 here. Look at this. It is 1 by 2. It is 2. 2 minus 3 into 1 by 2. So we get here 2 minus 3 by 2, which is 4 minus 3 by 2. Oh, sorry. 4 minus 3 over 2, which is 1 by 2 now. So we have got here 1 by 2. So we have got this first column as identity matrix 1 0 0. Look at this. Here we also get 1 0 0. The same process we have to do here. A inverse is equal to it is now the first row, there is no transformation, so we will write as it is. So 1 by 2 0 0. Here you see first I remove this. Now for this R2 we see R2 here R2 is 0, so I have to put here 0 minus 2 into R1. R1 is 1 by 2, so we get here minus 1. Here we get minus 1. Look at this now. It is 1. R2 is 1 minus 2 into 0, which is 1. It will remain same. 1. Here you see it is 0 minus 2 into 0, which will be 0. There would be no change. So minus 1 1 0. Now in the last row we see R3 tends to R3 minus 3R1. So you see here is the R3 is 0 minus 3. R1 is 1 by 2. It is minus 3 by 2. Just a moment. Minus 3 by 2. Here you see it is 0 minus 3 into 0, so it would be 0. Here you see it is 1 minus 3 into 0, it would be 1. So this we have got now here the right side. Now we have to make the second column as per the identity matrix, which is 0 1 0. So we have to make it 0 1 0. It is 1 already, so we don't have to transform this element here. We have to convert this 3 by 2 and 5 by 2 into 0, transform this into 0. So here you see we have to make this 3 by 2 and 5 by 2, convert this into 0. So we make for R1, so R1 tends to R1 minus 3 by 2 R2, and for R3 tends to R3 minus 5 by 2 R2. So this process we have to compile here. So this we have to do here. So we take R1. R1 is 1 here, minus 3 by 2 into 0. In the R2 it is 0, but the corresponding elements we have to take here. So get here 1, so there is no change, it would be 1. Okay, here you see it is 3 by 2, it is 3 by 2 minus 3 by 2 into R2 is 1 here, so we get here 0, so we get here 0. Here you see 1 by 2 minus 3 by 2 into 0. So we get here 0. So it is, no, we don't get here 0. Okay, it is 1 by 2 minus 3 by 2 into 0, it is 3 by 2 into 0 is 0, so it is equal, would become 1 by 2. So it is 1 by 2 now. It is 1 by 2. The second row would be same because there is no transformation in this row. So we write as it is 0 1 0. Now in the third row we have, look at this, R3 minus 5 by 2 R2. So we do here now R3 is here 0. It is 0 minus 5 by 2. R2 is also 0. So you get here 0. It is 0. Here you see R3 is 5 by 2 minus 5 by 2 and R2 is 1. It is 0 now. It is 0. Here you see 1 by 2 minus 5 by 2. Here you see 1 by 2 minus 5 by 2 and R2 is 0 here. So we get 1 by 2. It is 1 by 2. we have got this. The same process we have to follow on the right side for this R1. For this R1 is 1 by 2 here. Minus 3 by 2. R2 is minus 1. So we get here 1 by 2 plus 3 by 2. So it is 4 by 2, which is 2. Okay. So it is 2 now here. Now look at this, it is 0, R1 is 0, we have minus 3 by 2, R2 is 1, so we will get minus 3 by 2 here, we get minus 3 by 2. Here you see, it is again 0, minus 3 by 2 and there is R2 is 0, so it is 0, so we get here 0, okay. In the third row, we see R3 minus 5 by 2 R2. So R3 is minus 3 by 2 is minus 3 by 2 minus 5 by 2 and R2 is minus 1. So we get here minus 3 by 2 plus 5 by 2. It is 2 by 2 which will become 1. So it is 1 now. Here, and this would remain same because it is minus 1, 1, 0. There is no transformation in this row. So we have got 1 here. Now in this one, it is 0 minus 5 by 2 into 1. We get here minus 5 by 2. So it would be minus 5 by 2. And this one is 1. Minus 5 by 2 into 0, so it is 1. We get here 1. So this we have got second column as per the identity matrix 0, 1, 0. Now we have to this third column we have to transform. So first of all, we have to make this 1 by 2 is equal to 1. The diagonal elements would be, first we have to convert into 1, then other elements we have to follow. So in the identity matrix we know this already. You see in the third column we have to make this one R3. So the way by which R3 tends to R3 divided by 1 by 2, or we can write in this way also, R3 tends to 2R3. Okay. So here the first and second row would be same, there would be no change, and that because there is no transformation in these two rows. So we get here 1, 0, 1 by 2, 0, 1, 0. Now we divide it by, multiply 0 by any number, we get always 0, it is also 0. If we multiply this by 2, so 2 into 1 by 2 as per this process, so we get here 1. Okay, there is A inverse and these would both be same, the first and second row, there will not be any change. Here it will be multiplied by 2, we get 2. If we multiply it by 2 minus 5, if we multiply it by 2 we get 2. Now so we have to convert this 1 by 2 now into 0, we transform this. So R1 tends to R1 minus 1 by 2 R3, because R3 is 1 here. So if we multiply anything through this, so in the left side, now take a look of this R1. R1 is 1 here, minus 1 by 2 R3 is 0, it will be 1. There is no change here. It will be 1. This would be 0 and it is 0 here. R1 is 0 and 1 by 2 and R3 is also 0, so it would be 0. No change here. Now it is 1 by 2. Minus 1 by 2 and R3 is 1. So you get here 0. So here we have got not 0. There are no changes in other two rows, R2 and R3. It would be the same. 0, 1, 0, 0, 0, 1. Now the same process we have to do here. So here you see R1 is 2 minus 1 by 2 and R3 is 2. So we get 2 minus 1, which is 1. So we get here 1 now. You see R1 is 3 minus, R1 is minus 3 by 2 minus 1 by 2 into minus 5. So we get here minus 3 by 2 plus 5 by 2. It is 2 by 2 which would be 1. So we get here 1. Here you see it is 0. This one is 0 now. So 0 minus 1 by 2 and R3 is here 2. So we get here minus 1. Okay. It is minus 1 now. Other rows would be same. Minus 1, 1, 0, 2, minus 5, 2. So this is the inverse matrix of matrix A, because it has been converted, because we know that there is I into A. I into A inverse is equal to A inverse. So it is not I now, it is the identity matrix. This one is A inverse and this will also be A inverse. So we have got A inverse here. This is the way by the elementary operation we could find out the inverse of any sort of matrix. It is whether it is square matrix of order 2, order 3, order 4. So the main thing what we have to keep in our mind, first of all we have to convert as per the identity matrix the element into 1, then we have to convert other elements into 0. So in this way you could easily solve this.